Now we're going to talk about the second part of section 3.4, solving exponential and logarithmic equations. Solving logarithmic equations. Again, as we did in the last lesson, we're going to go through specific equations, and in solving those we'll learn the techniques. ln x equals 3. Okay, well, we know that we want to get x by itself because we're solving for x. And the way to do this is we use e as a base and raise it to ln x. And we use e as a base and raise it to 3. Okay, now this is not necessarily an intuitive step. That's why I'm showing you the technique. Is that when you have a log, of whatever base, and you need to get x by itself, you raise the base to that exponent. Okay, that's using the inverse property of logarithms that we learned before. And this will get x by itself. So that now we have x equals e cubed. And that, if you do it on your calculator, is 20.09. So practice that on your calculator, the number e cubed, and you should end up with 20.09. Now the main thing to learn in this example is that key step of raising e to the ln x power, and that is to get x by itself. Another example, log base 3, 5x minus 1, equals log base 3, x plus 7. This one is pretty clear that since they have the same base, you can simply get rid of the logs and set 5x minus 1 equal to x plus 7. And then, you can just rearrange terms as you would in Algebra 1, and you end up with x equals 2. Log base 6, 3x plus 14, minus log base 6, 5, equals log base 6, 2x. You should try to do this one on your own. So pause, do it on your own, and then resume. But I will give you a hint, and that is that you're going to use properties of logarithms to try to condense the left side. Okay, so pause, do it on your own, and then resume. So the first step is condensing using the properties of logarithms. Log base 6, 3x plus 14 divided by 5 equals log base 6, 2x. We simply used a property of logarithms. You can refer to those. If you want to just have those alongside you while we're doing these, that would be good. You can get them from your previous notes. And so since the logs have the same base, we can just write it as 3x plus 14 divided by 5 equals 2x. And then, of course, we multiply both sides by 5, and we have 3x plus 14 equals 10x. And then when we just do our rearrangement of terms, we end up with x equals 2. Another example, 5 plus 2 ln x equals 4. Again, pause the video, try to do this on your own, and then just resume it when you've tried to work on it and tried to get an answer already. So 2 ln x equals negative 1. We simply subtracted 5 from both sides. And then ln x equals negative 1/2, divided both sides by 2. And then the key step, getting x by itself. E to the ln x equals e to the negative 1/2. And then we have x equals 0.607, which you can evaluate on your calculator. E to the negative 1/2 power. Going on now to some more examples. log 5x plus log x minus 1 equals 2. So should be clear from what we did before that your first step is going to be to use a logarithmic property and try to condense the left side. Okay, so pause, do it on your own, and then resume. So the first step to condense the left side, we have log 5x times x minus 1 equals 2. And then we use 10 as our base because this is the common log. Common log has base 10. 10 to the log 5x x minus 1 equals 10 squared. And that will get the exponent 5x times x minus 1 by itself. It'll get that exponent by itself. And that'll bring us one step closer to solving this equation. So then we have 5x times x minus 1 equals 100. And I can simplify that, or multiply it out rather, to get 5x squared minus 5x minus 100 equals 0. Then I can factor out a 5 and get x squared minus x minus 20. And at this point, you should try to pause again, factor that yourself, and come up with some solutions. And then resume when you're done. X minus 5 times x plus 4 equals 0. That's the factored form. And if I just proceed as I would in Algebra 1, I would end up with these solutions, x equals 5 or negative 4. However, this is a warning. With these kinds of equations, you have to check each solution in the original equation, since one or more solutions could be extraneous. Alright, all that means extraneous is that it's a solution that doesn't work. And it's a solution that doesn't work because it's not in the domain of the logarithmic or exponential function. Okay, so let us check these solutions. We have 5 and negative 4. Let's put 5 in to the original equation. So going up to the top, you see log 5x plus log x minus 1 equals 2. Plug 5 in for x there, and you'll see that it comes out to be true. Alright, so 5 works as a solution. Alright, now try plugging negative 4 in for x in the original equation. Well, we run into problems because log 5 times negative 4 is log negative 20. That's impossible. You can never take the log of a negative number. Negative numbers are not in the domain of the logarithmic function. And we also run into problems with log x minus 1. If I put negative 4 in for x, well, then I end up with log negative 5, and that doesn't work either. So you can see that negative 4 is an extraneous solution. In other words, just a solution that doesn't work. So my final solution is x equals 5. That is the only solution to this logarithmic equation. Now here's a similar equation, log x plus log x minus 9 equals 1. And you should use the techniques that we used in the last screen to solve this problem. So pause the video now. Do this entire problem on your own, and don't resume until you have it completed. Okay, so now this is the solution. We condense first. Log x times x minus 9 equals 1. And then we raise 10 to the exponents on both sides of the equation. And this is because we want to get x times x minus 9 by itself. So we have x times x minus 9 equals 10. And then x equals 10 is my final solution. Now, obviously, I didn't go through all the steps this time, as I did on the last screen. But the method of solving this equation is exactly the same as what we did last time. And, of course, there is an extraneous solution also here. So when you plug in the solutions at the end as a way to check them, you do only end up with x equals 10 as your final answer. Another example, 2 log base 5 3x equals 4. Log base 5 3x equals 2. We divided both sides by 2. 5 to the log base 5 3x power equals 5 squared. 3x equals 25. X equals 8.33. Alright, so before going on, make sure that you understand these examples. The one that I didn't show all the steps for, of course, was the first example on this screen. But the method and steps for solving the first example on the screen are really identical to the steps for the problem on the previous screen. So you can, rewind, replay, whatever you need to do to understand these examples. Now we're going to do a word problem. If I invest $500 at 6.75% compounded continuously, how long will it take to double my investment? Alright, so just for practice, you should already be able to recognize which formula you're going to need to use. And then you've already learned the method, so try to do this one on your own completely, and then don't resume the video until you have an answer. So we start with our continuous compounding formula for interest, and we have A equals PE to the RT. Well, A is my final amount, and since the problem is asking me about doubling the investment, well, 1,000 is the double of 500. So that's why I put 1,000 down as my final amount. And then, of course, I plug in 500 for P because that's my principal, the amount that I first invested. And my R is 0.0675. And T is what I'm trying to find. Okay, so you should have definitely been able to set up the equation and come this far on your own. Now we divide both sides by 500. We have 2 equals e to the 0.0675t. Then using techniques that we learned earlier, ln2 equals ln e to the 0.0675t. That's going to help us to get t by itself. ln2 equals 0.0675t. And finally, ln2 divided by 0.0675 equals t. And I can just do that on my calculator. And since you did this problem on your own, you should have come up with this answer. T equals 10.27 years. So if I invest $500 at 6.75% compounded continuously, after 10.27 years, I will end up with double of the initial principal. The classwork, page 254, please write down these numbers, and we'll work on these in class, but as always, you can get a head start on them if you want.